All right, everybody. Today we are going to do trig functions of any angle. This is section 4.4. So first we're going to talk about trig ratios of any angle. So for any point on your unit circle or in the coordinate plane xy, the radius equals x squared plus y squared and the square root of it. Think of it like a triangle and the Pythagorean theorem. So if this is your y and this is your x, this would be your radius, right? Because from the center to the outside of the circle is the radius. So we have x, y, and r. So now, thinking back to what we learned about the trig functions of any angle, if you're here at theta, where I just drew this little line, the sine of theta would be opposite, which is y, over the hypotenuse, and the hypotenuse is the radius. So your sine ratio is y over r. Now with cosine, from the same angle that I drew, I'll go over it in like a reddish pink so that you can see it. There it is, reddish pink. So from that angle, cosine is adjacent, so x over the hypotenuse, which is r, so x over r. Tangent is, the same tangent ratio that we've been doing, y over x. And now the inverse trig functions are just the same that we've been talking about. They're the inverse of sine, inverse of cosine, inverse of tangent. So cosecant is now r over y, secant is r over x, and cotangent is x over y. So those are your ratios for any point that you are given. They are very similar to the ones that we have been working with. All right, so now we are going to apply those ratios that we just learned with this problem. So it says let P equal -3, -5 be a point on the terminal side of theta. Find each of the 6 trig functions of theta. So first what we're going to do is we're just going to draw a little sketch and figure out where P would be. So let me open up the pen. Since the -3 is x and the -5 is y, they are both negative, we would be over here in quadrant 3. So because they're both negative, we're going to be over there in quadrant 3. So that is where the point would be, and that means theta would be this angle here. That would be theta. So now what we're going to do is we are going to find the 6 trig functions. And if we want, we can make it a little triangle where this is your y, this is your x, and this is your r. So now you can see how we can really apply those ratios. So first we will do sine. So the sine of theta is y over r. Now notice we don't have an r. So in order to get r, I'm going to come over here and I'm going to do r equals x squared plus y squared. So it's basically like you're finding the hypotenuse of a right triangle using the Pythagorean theorem. So r equals -3 squared plus -5 squared and the square root of that. So r is going to equal the square root of 9 plus 25. R is going to equal square root of 34. So for this sine ratio, y over r, we're going to have -5 over root 34. Now keep in mind we cannot leave the root 34 in the denominator, so we have to rationalize the denominator by multiplying top and bottom by root 34 over root 34. So your final answer is -5 root 34 over 34 after you rationalize. Now let's go to the cosine. So cosine of theta is going to be very similar, except now it's x over r. So we're going to have -3 over root 34. Again, you can't leave the root 34 in the denominator, so you have to rationalize. So you're going to multiply top and bottom by root 34. And your final answer is going to be negative 3 root 34 over 34. Next, we're going to have the tangent. So the tangent is just y over x. So we get a little bit of a break here. We get negative 5 over negative 3, which is just 5/3. So again, we're just applying those ratios. The image I drew over here, where now I'm just putting the arrow, that's really helping me create a visualization of what x is, what y is, what r is, and where I am. So we have 5 over 3 for tangent. So now let's move to, just switch up the colors. Let's move to cosecant. Oops. Let me erase that, make it a little neater. Cosecant of theta, which is r over y. So this is root 34 over negative 5. So we don't need any rationalizing there. So now we'll come and do the secant of theta, which is r over x, which is root 34 over negative 3. Again, no rationalizing needed. And the last one we have is the cotangent of theta, which, using those ratios, is x over y, which is negative 3 over negative 5, which is 3/5. So those are all your answers here. Those are the 6 trig functions using any point. Make sure you draw that little image, and you're also going to have to find the radius. So that is how you answer this. All right, so now we're going to talk about the signs of the trig functions. So in quadrant 1, I'm just going to open up the pen. So in quadrant 1, this is Q1, all the functions are positive. Like this image here, this shows quadrant 1. The point xy, everything would be positive. In quadrant 2, that is right here, Q2 goes with this. If you see any point, the y would be positive and the x would be negative. So that's why the sine and the cosecant are positive. Because in quadrant 2, on any grid, x values would be negative and y values would be positive. In quadrant 3, that's right here, in quadrant 3, tangent and cotangent are positive. This is because the tangent and the cotangent ratio are x over y and y over x. So when all of it is negative and you divide a negative by a negative, you get a positive. So that is why cotangent and tangent are positive in quadrant 3. In quadrant 4, so there's this last one. In quadrant 4, cosine and secant are positive, right? Because secant is the inverse of cosine. And in quadrant 4, the x values are positive and the y's are negative. So that is your Q4. So if you're having trouble, just pick any point, right? If you picked a point in quadrant 4, let's say right here, this would be at 4, -6. I'm just making these numbers up. You can see that the x is positive, the y is negative. So that's why cosine and secant are positive. All right, so now we're going to find which quadrant the angle lies. So the first thing I'm going to do is I'm just going to draw a little coordinate grid, and I'm going to cross off the quadrants as we go. So this is 1, 2, 3, and 4. So we just have to remember what is positive where. So it says if tangent is greater than 0. So when you're greater than 0, that means you're positive, and cosine is greater than 0. So that means you're positive. So we need to cross off all the angles that, or all the quadrants that tangent is negative and cosine is negative. So in quadrant 2, cosine is negative, so it can't be that. And in quadrant 4, the tangent is negative, so it can't be Q4. So I'm between 1 and 3. So the answer here has to be quadrant 1 and cannot be quadrant 3. It can't be quadrant 3 because the cosine is negative in Q3. So in quadrant 1, everything is positive. So the answer for this has to be Q1. So a little recap, it can't be Q2 because they're both negative in Q2. It can't be Q3 because cosine is negative in Q3. And it can't be Q4 because the tangent is negative in quadrant 4. So that's that one. This one under it, we're going to draw another grid. 1, 2, 3, 4. Now, sine is less than 0, so that means that's negative, and cosine has to be negative. So there is only one quadrant where sine and cosine are both negative. In quadrant 1, they're all positive. In quadrant 2, sine is positive, and in quadrant 4, cosine is positive, so it has to be Q3. It is the only quadrant where the sine and the cosine are both negative. All right, evaluating trigonometric functions. So given that the tangent of theta is negative 2 over 3, and the cosine of theta is less than 0, we want to find the cosine and we want to find the cosecant. So there's a couple things we need to do to solve this problem. Open up the pen here, make it a little thinner. All right, so first that we have the tan of theta is negative 2 over 3. So the first thing we're going to figure out is the tangent of theta is negative 2 over 3. Is the 2 negative? Is the 3 negative? Where are we positive? Where are we negative? So remember, tangent of theta is y over x. So if cosine is less than 0, that means the cosine has to be negative. So that means for the tangent of theta being negative 2 over 3, it's really 2 over negative 3. Why is it 2 over negative 3? Because it gives us right here, where I'm drawing this little star, it gives us that cosine is less than 0. So that tells me that if we were to draw this, we would be in quadrant 2 because the x is negative 3, the y is 2, so you're at negative 3, 2. So there we go. So now that we've established that, we can work on building our cosine and our cosecant ratios. So cosine of theta is x over r, and we do not have the r yet. So we need to figure out how to, we need to find r before we do anything. So I'm going to find r using the formula that we used in the beginning of the video. R equals the square root of x squared plus y squared. It's always a good idea to make sure you have x, y, and r because you're always going to need a combination of those three. So r equals the square root negative 3 squared plus 2 squared. R equals the square root of 9 plus 4. R equals root 13. So now I come back over here to my cosine, x over r. I'm going to have negative 3 over root 13. Obviously, very repetitive. We cannot leave the root 13 in the denominator. So I'm going to have square root of 13 over, I'm going to multiply by square root of 13 over square root of 13. And I'm going to get negative 3 root 13 over 13. Now for cosecant, my ratio is r over y. If you weren't sure if it was r over y, look back at your notes from the first slides. So that's going to be root 13 over 2. And you are done. So that is how you find the ratio of cosine and cosecant just given that tangent. It's very important that they told us that cosine was less than 0 because that helped me figure out if the x or the y was negative. All right, so now we are going to talk about reference angles and how to find them. So a reference angle is an angle formed. It is a positive acute angle, so you should take these notes. It is a positive acute, meaning less than 90. It's a positive acute angle, theta, theta, formed by the terminal side of theta and the x-axis. The x-axis. So I'm going to show you what this means. So it's basically a positive acute angle formed by the terminal side and the x-axis. So you have 345 degrees. So I'm going to draw that. 345 degrees is in quadrant 4. So it's all the way over here. So that's 345 degrees. So its reference angle, I'm going to highlight in green. So this is the terminal side of theta in green. That's the side that moves. And the x-axis, which I just highlighted. So this right here is your reference angle. So that is just going to be 360 minus 345, which is 15 degrees. So 15 degrees. So again, it is a positive acute angle formed by the terminal side of theta and the x-axis. So there you go. When theta is 345 degrees, the reference angle is 15 degrees. All right, letter B. Now we're going to do one in radians. So we have 5 pi over 6. So 5 pi over 6. So now I'm going to draw a little grid. 5 pi over 6 is located in quadrant 2. Remember, quadrant 2 is a full pi, 180 degrees. So if this right here in pink is 5 pi over 6, we have to figure out what this piece remaining is. Remember, the x-axis, terminal side. That is going to be your reference angle right in here. So that just becomes pi minus 5 pi over 6, which is pi over 6. So 1 whole pi minus 5 pi over 6 is pi over 6. That is your reference angle for letter B. All right, so for letter C, we have theta equals negative 135 degrees. So I'm going to start the same way. Remember, when you have a negative angle, you are going clockwise. So I'm going clockwise, negative 135. So that's 90 and another 45. But remember, my reference angle is formed by the terminal side, which I'm going to highlight in green, and the x-axis. That tells you if you went negative 135, the amount you need to get back to the x-axis would be 45 degrees. So your reference angle is 45 degrees. That is how much you need to get back to the x-axis. 45 degrees. Always go up or down to the x-axis. That is your reference angle, because your reference angle, again, is positive and it is acute. So d theta equals 7 pi over 6. Guys, I'm going to go to the unit circle and just show you how to do this one using the unit circle. So here I am at the unit circle. Get this pen up. So here I am at the unit circle. I'm doing 7 pi over 6. So there is my angle for 7 pi over 6, 210 degrees. There it is. Now remember, my reference angle is formed by the terminal side, which I'm now highlighting in green, and the x-axis also highlighting in green. So this angle right here is your reference angle. So that's why I just said you guys need to work up to the x-axis from the angle. So from 7 pi over 6 to pi is an extra 30 degrees, or pi over 6. If you're having trouble with radians, you can convert into degrees, but if the question is in radians, the answer has to be in radians. So use your unit circle. It's there for you. You see 30 degrees is pi over 6. Remember, these reference angles are acute, so they're going to be between 0 and 90 degrees. So that is how you use your unit circle to find the reference angle. Okay, the last thing we're going to do is we're going to use reference angles to evaluate trig functions. So we're going to basically use the reference angle to help us solve the problem, to evaluate the trig function. So first we have the sine of 135 degrees. So I'm going to start off the same way, and I'm going to find the reference angle first. So the same way we did in the last example, I'm going to draw 135. It's right here, 135 degrees. Now remember, our reference angle is formed by the terminal side that I'm highlighting in green and the x-axis. So our reference angle here is this that I'm highlighting in green. So if the blue is 135, the green is what's left over is 45 degrees. So now I'm just going to take the sine of 45 degrees. The sine of 45 degrees you would get right from your unit circle is the square root of 2 over 2. And again, you would get that right from the unit circle. So that is how you do use the reference angle to evaluate the trig function. So the next one we have is the cosine of 4 pi over 3. So again, I'm going to draw it. And guys, if you're not sure where the cosine of 4 pi over 3 is, simply go to your unit circle. Your unit circle, 4 pi over 3. It's right down here, 240 degrees. Go to your unit circle to figure it out. Then you go back to the slide. So 4 pi over 3 is, oops, sorry about that, is down here. So 4 pi over 3. Now remember, our reference angle, I'm going to highlight in green, is this angle. So again, if that's 4 pi over 3, this remaining part would be pi over 3. And again, if you don't know that, go back to your unit circle. See? Sorry about that. If you look there and there, your reference angle, oops, hold on one sec. Your reference angle is this. This is your reference angle. So your reference angle is 60 degrees, which is pi over 3. It is pi over 3. So to come back, our reference angle is pi over 3. Then we just have to find the cosine of pi over 3, which again, you would use your unit circle for. You'd go to the unit circle, the x-coordinate is the cosine, and it ends up being 1/2. 1/2. Okay, last one for the day. Cotangent of negative pi over 3. It's a little bigger. Cotangent of negative pi over 3. So again, I'm just going clockwise, pi over 3, which is negative pi over 3. Then I need to figure out the reference angle. The reference angle is exactly what we went. So we went negative pi over 3. The reference angle is just back pi over 3. I'm going to highlight that in green. So the reference angle ends up being pi over 3, and we just have to take the cotangent of pi over 3. Remember, cotangent is x over y. So we might have to go to the unit circle. go to the unit circle. At pi over 3, these are my coordinates. So I'm going to have to do x over y with those coordinates. X over y with those coordinates. So we'll bring those back to the other to the presentation. So we have 1/2 and square root 3 over 2. So cotangent is x over y, so it's 1/2 over root 3 over 2, which is 1/2 times 2 over root 3, which ends up being 1 over root 3. Have to rationalize. Ends up being root 3 over 3. And that is going to be your cotangent. Now, the last step that we need to be cautious of, because we are in quadrant 4, the answer is not just root 3 over 3. Because we are in quadrant 4, it has to be negative root 3 over 3. Because we should know cotangent is negative in Q4. Also, just to go back to part B, I actually forgot to put it. This has to be negative 1/2. So just put that negative there, guys. Negative 1/2 because the cosine is negative in Q3. So it's important that you know what quadrant you're in so you don't make a mistake like I just made and forget the sign. So be very cautious of what quadrant you're in. So just to reiterate, in part B, you're in Q3, so the cosine has to be negative. In C, you're in quadrant 4, so the cotangent has to be negative. And that is all your notes for 4.4.